Hey guys, this is Eric Weingart with Weingart Racing, and I thought I would do a video on actually how to assemble a set of heads. I've done one something similar, but not as in depth, so I thought I'd go over it with you. So there's a lot of steps that took place before this to get the head actually ready for assembly, but we're at to this point. These are my Dragon Slayer 242s. They're ported and they're ready for assembly. So what you've got, your basic parts are your valves, you got your springs, and the retainers. These are locators, locks. Now I'll explain how all these goes. All right, first off, the thing you're trying to do is pick your spring. The spring has to match your cam. Typical, most springs will include this little thing here, and it tells you the installed heights and the spring pressure that come with them. So that kind of gives you an idea of how much spring pressure there is. But we're gonna go ahead and check these anyway, but this is what you're looking at. So what it says here is, if you notice, it says 250 pounds at 2 inches. This means at 2 inch installed height, and I'll explain that here in a second. And this also tells you a coil bind. Now, if I know it doesn't tell you the max lift, and there's a reason for it, we'll get to that in just a second. So I'm gonna actually target for a 198 installed height, and the reason for that is it will actually should give me more spring pressure than that. So I'll show you what I mean in just a second. I'll go ahead and start by telling you this too. I am not a video editor, so you're about to see a bunch of splices because it's just me filming, so I got to kind of put these together. So bear with me as I try to go through each thing. Now, if you noticed just a second ago, I said I was shooting for a 198 installed height. The reason for that is I was actually shooting for 265 pounds on the seat as far as pressures goes. So if you look, this is a Buxton valve spring tester. What it does is you put a spring in here, and it will measure, you can tell it to how many pounds you want that seat, and it will tell you, well, what installed height you'll get it at, and it will also tell you how close you are to cool bind and that sort of things. So this is what it does, is this is telling me at 198 installed height, I actually have 265 pounds of pressure. Now, if you notice on the box, it said you had 250 pounds on the seat at 2 inches. Well, at 198 measured is 265. Now, if you also notice, I'm showing you this, I measure them with the retainer installed. And the reason for that is because there's a retainer has a step. Let me see if I can't grab one real quick. Sorry for the bouncing of the camera. So the retainers have steps, and what happens is it's touching the spring at different times. So if you measure your spring pressure without the retainer installed, it's typically less because this step actually touches the spring and the inner spring and causes it to collapse a little like it's supposed to. So you try to measure it exactly as it would be on the head, and of course we have the retainer installed, so that's how it is. So what this is telling me is if I want 265 pounds of seat pressure, I need to have the installed height of 1.98. So this gives me where I want to target from. All right, here we have some of the components that I'll try to explain as we try to install the head. So remember, our target installed height was 1.98, but this is to show you kind of some other stuff, some little bit of bonus material. The first thing is, since it's aluminum head, you always have to use something like this. This is called an inside diameter seat locator. And what it does is this sits in the pocket like so. See, this is right inside the pocket. And what happens is the spring sits inside of it like so. And it sits like that. And the reason for that is it protects the head from the spring digging in. If it was a, let's say without it, as the spring rotates naturally, it's going to eat into the aluminum. So you can't have that. So you have to have this. I prefer the inside diameter seat locators like so, and the reason why is I feel like it guides and holds the spring better. But the biggest thing is you just have to have something between the aluminum here and the spring. Now, Brodix itself, that's what these heads are, their pockets are actually 155, which means that spring, if you set it in here anyway, because the other purpose of this ID locator is to keep the spring from moving, because you don't want it walking back and forth to wear out a guide. So, but in Brodix, they have the pockets drilled where it kind of holds the spring from really moving too much anyway. So you don't actually totally need an inside diameter locator. You can use just a shim, and I'll explain that. Sorry, I had to grab one. These are shims, and what you notice it just like this. When you get heads ordered from Brodix, they just put the shim. They put it in there, and then they put the spring in there. And the idea is you're protecting the head, and the spring really can't move because the pocket kind of holds the spring. And that's correct. I just don't prefer it that way. I'd rather use inside diameter locators. To me, it feels like it's a more sturdy thing. However, since I'm trying to teach you, you don't necessarily have to have them, but you definitely have to have some hardened steel piece before the spring. The other reason why I don't like using shims so much right underneath the spring is because the springs will eat up these shims, especially if you're like a 30 thousandths diameter shim. It will try to eat those up, and that just puts metal on the engine. The inside diameter locators are 60 thousandths thick, so they're thicker, so they're more durable, I guess you could say. So there's that. Now let's talk about something else. Locks. The locks have to match your retainers. And what I mean by this is if you pick up your retainers, they should say on there, somewhere on the box, what degree they are. And this one says lock angle 10, which means it's a 10-degree lock angle. So you got to be aware of that. And these are comp locks. And if you look on there, it says super valve locks 11/32. You're like, oh my gosh, I'm not for sure. Well, I can tell you because I've used enough of these. These are a 10-degree lock. Now, if you ever get a retainer and you're uncertain of is it 10 degree, you can get one of these tools like this from Ferrea. And this, you just shove it into the inside and it will tell you if it's a 7, 8, or a 10. And that's what you can use. But if you don't have those, the best is just check your manufacturer and it should be there. So make sure your locks match the angle of your retainer. Speaking of locks, not all valve locks are the same. So these are 10 degree. I like using these and they're fine, but it's really hard to capture on this because they're black. But these are square grooves. Can you see the groove in them? These grooves have to match your valves. So there are actually several different grooves, I should say, that come in on valves. You just have to be aware. Most of them that you get for small block Chevy are like this. They are square groove. You can see it there. That valve tip's made to go with that lock. However, let's say you got an LS. Can you see the groove on the valve? They are different. LS uses something called a radial groove. That's where it's curved. These use a different lock. If you try to use these square locks on that valve, you will have issues. You'll probably drop a valve. Consequently, if you try to use radial grooves on a square valve, you will also have issues. And yes, I have seen people bring in heads that are like this, and it has torn up some stuff if they're lucky enough. If they're unlucky, it has destroyed their engine. So make sure if you have a square valve, that you have square grooves that go with them. If you have a rounded groove like this, you have a radial lock that goes with them as well. And then also make sure that the lock angle matches the retainer angle. Now we can actually go to the rest. All right, this right here is called a valve spring installed height mic. And what you do is you use this to determine your actual installed height. Now, if you remember earlier, I am targeting a 1.98 installed height because that'll give me 265 pounds on the seat. So what you do with this, if you ever see them, they're about 50 bucks. The higher priced ones go up to like 120. Anyway, what you do is you'll see this, is you take your retainer, you put it over the top, and then you slide it over the valve, and then you twist it out with the locks in, and you twist it, and it will give you a measurement. Now, if you notice here, mine says, this is a 2-inch one, by the way, so when it gets to 0, it means it's exactly at 2 inches. So really what it's saying is I have, camera's getting fuzzy on me, 2.025 installed height. But I'm not wanting that, I'm wanting 1.98. So how do we get there? Let's do some math. Since I have a 2.025 installed height, and I'm wanting to get to 1.98, if I subtract the difference, I get 0.045 difference. So in other words, if I add 45 thousandths of shims, and that's what these are, underneath my inside diameter locator, you don't put it on top, it will give me my 1.98 installed height. Now shims come in 3 different thicknesses. We have a 60 thou, a 30, and a 15. Now, because I need 45 thousandths, the only way we can do it is to do a 30 and a 15 together, and that should make 45 thousandths. So I'm going to shove it underneath there and remeasure my installed height. Okay, so I put the shims underneath and I remeasured, and look, it is 1.98 like it's supposed to be. Now, I might have confused some of you, so I'll show you what I mean. I'm trying to be as simple as possible. You take the shims you use, you put those in first, then you take your inside diameter locator and you put those over that. So the shims are always underneath the inside diameter locator, never on top. And then you remeasure. So this is the exact height, and that's good. Now you would assume at this point that you are done. You now can add, according to this, We took a 30 and a 15 thousandth shim. That's how we got these. And you put underneath all these and you should be good. If you did that, you'd be incorrect. The biggest reason is because the installed heights typically are different between the intake and exhaust. You're like, how can that be? I mean, if you set your valve jobs are all set at the same height, they should all be the same. Well, there's a little bit of things that come up. So I'll show you one. Here's the biggest one. These both valves, both the intake and exhaust, measure the same length from the factory at 5.010. But if you look at the valve itself, this bottom part here is called the margin. If you look at the margin for the exhaust and for the intake, not the seat angle, but the margin, I'm sorry, that's a real thin part here. The exhaust is always more. And the reason why that they put more margin on the exhaust is because it has more heat in it, and if you can prevent them from cracking, there's usually a thicker margin. What that means, however, what we're doing is there's more of the length on this side of the valve and less up here, which means the installed height typically on an exhaust valve is less than it is for the intake, because since there's less margin, that means it's moved the valve up, which means we have more installed height on the intake than we do for the exhaust. So what's that really mean? It means you have to check both the intake and exhaust. Now, if the head was perfect, you'd only have to check just the two, and then you could do all the same for the rest. You know, whatever you did on the intake, you do it on all the intakes. Whatever you did on the exhaust, you could do for all the exhaust. But that's a perfect world, and we don't live in it. Several times I've seen where the valve job is perfect on the deck side, and I come here, and on every head I have assembled, I check the installed height on every single one. And sometimes they're different shims. And people think, well, you just did it wrong. No, I checked everyone, because there are several times where manufacturers, especially AFR for whatever reason, the last one, and I don't know if their machine program got messed up, but it's sitting lower by 5 or 10 thousandths. So what that is its installed height ends up bigger than the rest. So you have to check. It's very important to check each one. So I'm going to go ahead and show you. So we did the exhaust already, so let's go ahead and check the intake, and then we'll see what shims we have to add underneath that real quick. Okay, so I put my valve stream mic on this, and if you notice, I am way more. Because like I said, there's less margin on the intake, so it moves the valve up. Also, typically the intake valve job also sits down a little bit lower, so regardless, it ends up with this. So if you look at this, we're almost 2.05 compared to, remember that was the exhaust, 2.025. So if I do the math, this is where we are at now. No shims. The installed height on the intake is 2.050. Remember, I want the 1.98 installed height. When I subtract what it is from what I want it to be, it means I've got a 70 thousandths difference, which means I have to put 70 thousandths worth of shims underneath there to get 1.98. Now, if you remember earlier, I said the shims only come in 15, 30, and 60. So if you notice, if you do the math, 60 plus 15 is 75. So it's 5 thousandths over. There's no way to get a 70 thousandths shim. They just don't exist. There's no way to get that exact 70 thousandths. So instead, what you do is you take a 60 and a 15, and that's 75. It's 5 thousandths over that, which means my actual installed height would be 1.975. So it's 5 thousandths less. So what's that mean? Well, if you look over here, this tells me my bind clearance at 1.98. And if you notice, it says I have a 0.065. Well, if you take 5 thousandths away, I'd have 60 thousandths. Between 50 and 60 thousandths is the minimum you could have before max lift as far as coil bind goes. This says that at 780 lift, by the way. So I've still got room for that, and it will fit. 5 thousandths really won't change the spring pressures all that much anyway. So and since it's the intake, and intake valves typically way heavier, I'm going to go ahead and add that extra 5 thousandths instead of removing it. Because I could either do, if you look at it, I could do a 60, which would put my installed height at 1.99, or I could put the 60 and a 15, which puts it at 1.975. So I'm going to go ahead and run a 60 and a 15. And I'm going to shove those underneath there, and that's what I'll run. Now that I know the installed height and how much shims I need to add underneath each one, a good thing you could do is write them down on each one. So what I'm going to do is I'll go ahead and write down on this one how much shims I'm going to have, and then on this one how much I should have. Now, after you've got them written down, you should do the same thing we just did. Check the installed height on this one, this one, this one, and all the rest down. Typically, they should be the same. But like I said before, because of manufacturing differences. Sometimes you can have a spring pocket that sits too low, or sometimes you can have where the valve job's too less, or where the valve's not ground the same length. So you got to check all of them. I highly recommend it. And then, by the way, you don't just use the same valve and check all. I like to put this valve that's going to be in this hole, I've checked it, and then I put it to the side and I grab the next one. In other words, I don't keep using that same exhaust valve for all of them, because you can have differences in exhaust valves and intake valves. So I'm making sure that each valve matches each hole that it's going in. It takes longer, and I don't know that you necessarily have to do, but it's good practice. Now you would think, well, good, now I'm done. I can just slap these together. There's one more thing you need to check. And this is called, and I just dropped it. This is called retainer to valve stem seal clearance. What this is this is the retainer, and that's the valve stem. Now I've already put one on. Usually when I sell valve stem seals, if you need them, I usually put 18 in the bag, even though you only need 16. One in case you damage and then one to check. And the reason for that is you'll put it on, and then what you'll do is you'll take your dowel calipers like so, and then you measure the distance from, I'm trying to get my camera in here, distance from there to there. So I'm there we go. From the top of the seal to the bottom retainer, and you'll get your distance. Now in this case, I've got, trying to do it right, 0.856. What you want to have is 60 thousandths before you're at max lift. In other words, when the valve goes all the way down, so let's say it's got 780 lift. If it comes down 780 thousandths, I still should have another 60 thousandths before this retainer touches that seal. That's retainer to seal clearance. Because what can happen is if you pick too short of a valve, but maybe you got the correct installed height, the retainer can actually smash into this. That's not good at all. Especially because if it smashes into it, what it can do is it can unload the retainer, and then the valve locks can become loose, and it actually can drop a valve. Not a good thing. So if I look at this, it's 0.856. If I take 60 thousandths out, it's just a hair under 800 thousandths. So like 0.794, if my math's right. Remember, we set the springs up 0.780, so there's enough room here. But you should always check it. It's good practice. You need to do that. Once you've got that accomplished, then you can assemble the heads. And I'll show you some tricks as I'm doing that. Okay, here we are to the next step, and it's a word about seals. What I've done already is I've installed the shims, and they're underneath the seat locators. Now it's time to install the actual valve stem seals. These are what I use. These are a Viton with a metal clad, and it protects them. And these are what I use. This is shit. Okay, so if you see a head with these on them, they're shit. If you see a head with these on them, they're shit. Don't use these. No good engines use these things. If they do, it's because they're out of other ones. So these are what I use, and they're from SI. Very good. They seal up, and they work like they're supposed to. You might say, what do you have a problem with those? Those are plastic. Okay, yeah, they kind of do, but if you know anything about plastic, as they heat up and cool down over time, they crack. So it isn't good. Now, when you order heads like these, let's say from Brodix, they're only going to include 8 of these. Now, these are Brodix ones. They look identical, don't they? They look like theirs. The difference is like Brodix's press on the inside is way tight. So you end up having to beat them on pretty hard. With mine, you can shove on with the tool. So let's talk about how to actually install them. First, here's what I do. I take them like this. I'm trying to do 2 things at once, so bear with me. But what I'm going to do is I'm going to remove this spring on the outside. Okay? I can't hold them both at the same time, so bear with me in this. So I've removed that little spring on the outside. Now this is the valve stem installer tool. As you can see why it's a mushroom, because I had to beat someone in the early past. I've had this thing for years. What you'll do is you'll shove it inside there. This is really hard to do with just one hand. So you put it in like so. Okay, and then I put it over my valve stem. And then you just wiggle it on and push it in until it goes all the way. Now you'll notice when it seats all the way, because you'll feel it click in like that. Now the reason why you can't do this with Brodix ones is because if you try doing that with a Brodix one, it will go a little way and stop. They're just so tight. There's nothing wrong with them. They're harder to install. Now, you notice the spring's still missing. Now you install the spring. This is it. It just slides back over. You might say, why did you take it off? Well, sometimes that tool can damage this spring where it kind of gets messed up. So just to save it, that's what I do. So now I'm going to put them on all of them, and then I'll put the valves through. All right, now to put the valve in. Now, every valve cannot just be put in without some kind of lubricant on it, because you're going to have a dry startup, so you got to have something. What I use, and you can use a variety of things. I don't know that it's super critical about what you do use. Although, please don't use white lithium grease. This is what I use. It's Clevite bearing guard. You can actually use this to assemble engines. There's also other stuff you can use, like Roll Purple has assembly lube that works well too. There's all kinds. Anyway, just all I do is run a light bead down the top and through the groove. Then I'll put it in the guide itself. That's hard one-handed. I'll spin it, so it makes it all around. Then I put it through and go back and forth with it, and then I just push it through the seal. That's it. I do it on all of those. Right. Now, to assemble the actual head, the actual process of doing it, or procedure, I realize I assemble heads differently than others. Most people lay the head down, so like in the horizontal position. I assemble my heads in the vertical position because I feel like I get better eyesight for what I need to do. Now, I've got this MTI pneumatic valve spring compressor, which I understand for most people, if you're just doing it on your own, would never own one of these. These things cost about $1,200. But for probably 5 years, and when the business had opened, I was using something like this. This is a Proform valve spring compressor. If you want to have a shoulder workout, you don't want to go to the gym, just assemble a few heads with this dude. Especially if you got like spring pressures in the 1200 range open. Yeah, I did it with these. It is a workout. You can tell it will bend this shaft here. But I did it for years. You can do this with these, and it's not a problem. With this spring setup, it's not too bad to do. On definitely the stronger springs, it's very cumbersome. But anyway, here's your tip for you. If you choose to do it in the vertical position like I do, what I do is I take Vaseline and I put on all the grooves of the valves all the way down first, and then I put my locks over the side. And what I'll do is I'll take my spring and I'll pop it in. The reason why I put that on there is because I'll show you in a second, but it just holds the locks in place. So let me show you. Here's what I mean. This is how the valve spring compressor works. Look, I'm not holding it, so that's the reason why also for it. But anyway, what the Vaseline does is I've got a spring compressed, and then I just push the locks on like so. The Vaseline will hold them in place. So that's the reason for it. So when I release, the locks are already held. I don't have to actually have to hold them with my finger. I will say it's much easier to assemble a head when they have square groove locks. If you remember earlier in the video, I talked about that. Because radial grooves, what they want to do is the lock will actually try to roll out of the groove, but the square ones seem to hold it better. The difference is when you do that one, you just don't bring the valve spring compressor down as far. You bring it down just enough so you can engage the actual groove, and that's it. So all I have to do at this point is release, and it'll be on. So I'm gonna hold it because it's gonna fall. And boom, it's on. And I have to do that in all 16, and they are done. All right, there's one more thing I like to do after I send them. So what you just saw is me put them all together. What I like to do after that's done is I need to check to make sure everything's okay. So if you've assembled your head, you kind of want to check too before you put them in the motor, because it's kind of a pain to pull them back off. What I do is the heads that you get from me, they're vacuum tested at least 2 times. So the first time when I do the valve job, I just drop the valve on and see if it'll pull vacuum. This way it tells me the valve job is correct. Then after assembly, I'm going to do them again. So I'm going to do them right now. And what I mean by that is, this is my seat and guide machine. It's pretty dirty. I've got some work still I've been doing. But anyway, this is a vacuum gauge on it. And what I do is I'll take it and I'll vacuum test the port. I'm just going to do it on an exhaust port for the video, but I'll do it on all of them. I won't just do it on one, but just for the video's sake, I'm just going to do it on one. But I'm going to vacuum test it and make sure it's pulling a vacuum like it should. And what I do is I'll turn it on, and I've already done it, but I'll turn it on and it pulls right at 21 inches of vacuum with my thumb over the port. So this is what I mean. This is the port, and I put my thumb over it and it pulls exactly 21. For me to pass my test, when I pull on here, it should be no more than half a pound difference from perfect, and the 21's perfect. If it's more than that, usually there's some kind of issue. Now there's a couple reasons to do it for me. I ported these heads, so if there's let's say I miss something, which would be super rare, and there's a hole, the vacuum test will show it. But the other reason is to see if the valve job is sealing up. you want to make sure on this before, of course, you board them to your head and waste all that time. So I'll do one real quick. So I just kick on my vacuum tester. It might be a little loud. And see, if I put my thumb over it, it goes to 21. So I'm gonna attach it to the head. This is the plate. I'm just gonna attach it to over my exhaust port here. Remember, it just wanted me, so this is kind of a pain. It's sucking on there. And if I look back here, it's the same. So it's perfect. So it's, as you can kind of tell. Now I'm gonna do that on all 8 ports and all 3 frets. One final tip for you guys. So we've gone through this whole process of installation and showed you how to assemble a head. But if you notice, this is called dicom. This is what the blue dye is. It looks unprofessional if I was to send the head out that way, and maybe you're in the same position where you put some dicom on. And what dicom is, it's just a dye you put on metal to help you scribe stuff so you can see where you can stop porting and whatnot. But the thing is, how do you get rid of it? Well, this Behrman's, it works okay, but a lot of the carb cleaners and stuff will not take off dicom. What I've actually found works best is the Walmart brake cleaner. Don't ask me why, but that seems to be the best one. When you just spray it on a rag, for instance, I'm just gonna dab here. Ooh, a little bit much. By the way, you should probably use gloves because this stuff will absorb through your skin and probably leads to cancer or something. But anyway, you can tell it takes off nice. So anyway, that's one thing. It also will remove any of your Sharpie marks. Of course, you don't want that stuff on there too. So there's your little tip for you. After you got that, clean it all up, out the door, you're good to go. If you have any questions, feel free to give me a call. You guys have a nice day.